Inside a steel plant, the complete journey from iron ore mining to wire rod production. Steel is one of the most important materials in the modern world, supporting everything from buildings and bridges to vehicles, machines, and everyday tools. Behind every coil of wire rod lies a complex and carefully controlled process that begins deep in the earth and ends inside a high-tech steel plant. Iron ore mining, the starting point. The journey begins with the extraction of iron ore from the ground. Iron ore is a natural mineral found in rocks and contains iron compounds mixed with other elements such as silica and alumina. Mining operations may be open pit or underground, depending on how deep the ore deposits are located. Large machines drill, blast, and transport the ore to processing facilities, where it is crushed into smaller pieces to make it easier to handle. After crushing, the ore is screened and sometimes washed to remove dirt and unwanted materials. This step improves the iron content and prepares the raw material for further processing. Beneficiation and transportation. To increase efficiency, iron ore often undergoes beneficiation. This process separates iron-rich particles from waste material using magnetic separation or flotation techniques. The resulting concentrated ore may be turned into pellets or sinter, making it more suitable for use in steelmaking. Once prepared, the iron ore is transported, often by conveyor belts, trains, or ships, to steel plants. These plants are usually located near ports or major transport routes to handle the massive volumes of raw materials required. Ironmaking, turning ore into molten iron. Inside the steel plant, iron ore is converted into molten iron, most commonly in a blast furnace. The furnace is loaded with iron ore, coke, a form of processed coal, and limestone. Coke acts as both a fuel and a reducing agent, removing oxygen from the iron ore, while limestone helps remove impurities. At extremely high temperatures, chemical reactions take place, producing molten iron that collects at the bottom of the furnace. Waste materials combine to form slag, which floats on top and is later removed. Steelmaking. Refining the molten iron contains too much carbon and impurities to be used as steel. To refine it, the molten iron is transferred to a steelmaking furnace, such as a basic oxygen furnace or an electric arc furnace. Oxygen is blown into the molten metal to reduce carbon content and remove unwanted elements. Alloying elements may be added at this stage to achieve specific steel properties. The result is molten steel with carefully controlled chemical composition. Casting, shaping the steel. The molten steel is then solidified through continuous casting. In this process, the liquid steel is poured into water-cooled molds, forming long solid strands known as billets. These billets are the basic shapes that will later be rolled into wire rods. After cooling, the billets are cut to length and inspected for quality before moving on to the rolling stage. Rolling, producing wire rods. Wire rod production takes place in a rolling mill. The steel billets are reheated in a furnace to make them easier to shape. They then pass through a series of rolling stands that gradually reduce their diameter while increasing their length. The rolling process is fast and precise, producing long coils of wire rod with consistent size and mechanical properties. Controlled cooling ensures the wire rods have the required strength and flexibility. Final inspection and use. Once rolled, wire rods are cooled, coiled, and inspected for surface quality and dimensional accuracy. Finished wire rods are used as raw material for products such as nails, screws, springs, wire mesh, and electrical wiring. Conclusion. From iron ore mining to the final rolling stage, wire rod production is a remarkable combination of natural resources, advanced technology, and skilled engineering. Inside a steel plant, each step is carefully coordinated to transform raw materials into high-quality steel products that play a vital role in modern life.